Oh, well, now everybody's going to know that story. So my name is Robert Rubin. When I was little, my uncle Albert lived with us. We lived in a big rooming house. My parents, aunts, uncles, my grandmother, and they'd call Albert. So I'd show up and my uncle would show up. Usually it was my uncle they wanted. So after a while, it was, okay, you're Bobby. Okay, I'm Bobby. So the rest of that story is I got to the 7th grade and the teacher's calling roll. And she says, Albert Rubin. And I looked around and I said, hey, there's another Rubin in Riverside. Albert Rubin. This kid's so dumb, he doesn't even know his name. Is there an Robert Rubin here? Oh, Robert? Oh, yeah, that's me. So that's how I got to be Bobby, and that's, people know me as Bob Rubin, and my first name is Albert. So we're going to talk a little bit about water management. Got it? I guess I do that. Okay, we're going to talk about water management. If you have questions as I go through this, please ask questions. I promise I will finish in 45 minutes. I'll just stop and we'll go on from there. So before, I'm a professor, as you well know, or you may not know. Why isn't this advancing? Oh, I have to use that, not the.
Yeah, you can.
Okay, where do I put here? So what do we call organisms that synthesize food from atmospheric? I start with a test to test your knowledge. What do we call organisms that can take carbon dioxide out of the air and synthesize sugars? Huh? You're eating them. What do we call them? Plants, right? Yes. What do we call organisms that can live without oxygen? All of my wastewater treatment friends here that deal with that kind of digestion, what do you call that? Anaerobic, yes, anaerobic organisms. And this is the real key. What do you call organisms that can live without water? Dead. Yeah. So the moral of that story is we've got a finite amount of water that we've got to deal with, and it's going to be increasingly challenging to deal with those water resources. And if anybody wants to quote me anytime in the future, it's true. No organism can live without water. So we're going to talk about a bunch of different kinds of water, and it's all water. It doesn't make any difference. It's all water. Nature has been recycling water on Earth for billions of years. The amount of water we have has stayed about the same. We've lost a little bit to space, and when meteors come in and land, they probably bring a little more water with them. But the amount of water we have has been around for a long time. How many of you have a carton of water on? There's a carton of water right there. There's a molecule of dinosaur pee in that, what you call it. So we've been recycling water forever. You're eating plant material. There's nitrogen and phosphorus in that. I have really bad news for you. There's a little bit of nitrogen and a little bit of phosphorus in that was pooped by a dinosaur a couple billion years ago. We've been recycling for, nature has been recycling as long as we have been here. And what we ought to be doing, how many do work with water, solid waste? I know a couple of you. We ought to be encouraging more and more designs that rely on mimicking nature. I do work with constructed wetland systems. Constructed wetland systems have a lot of benefit when we look at ecosystems. I do a lot of work with water reuse, recycling, reusing water, recycling, reusing biosolids or residuals. And by and large, it's safe. What are the two chemicals that everybody is concerned about today? You read about them every single day in the newspaper. PFAS and PFOA. PFAS and PFOA have been around for 30 or 40 years. We really don't know health consequences that are associated with them, but we are developing management programs right now to look at how we're going to develop or manage PFAS and PFOA in the future. These cycles, they've been around long before I got on Earth. It's nothing new. And that's what our environmental management efforts are really aimed at doing, is fitting into that cycle a little bit more aggressively. What are some of the water sources we have? Well, surface water and groundwater. What do we see happening? What did we see happening in North Carolina about 3 weeks ago with our stream flows? They were way down. Much of central North Carolina was in moderate drought. We're really lucky here. We get these rain events and our river systems are replenished. They start in the Appalachians and they work their way on down to the coast. What is happening in the western part of the country today? Those watersheds start in the Rockies and they go all the way to the Pacific Ocean or all the way to the Gulf. And the status of surface waters in the western part of the country today is terrible. I don't know how you're going to get lettuce next winter because Arizona is not going to have water to irrigate those crops. The allocation to Arizona for water resources out of the Colorado River has been cut by over, you all know this, by over 50%. That's to supply people and that's to supply agriculture. I don't know how we're going to be able to do that unless those water resources are replenished. So that's surface water. What about groundwater? A lot of people in Eastern North Carolina rely very heavily upon groundwater. We have a couple of major groundwater withdrawers in Eastern North Carolina, and those cones of depression are getting deeper and deeper and wider. So they're having more and more influence on the availability of water to people in Eastern North Carolina. I know places here in Wake County where, I don't live in Wake County. I know places here in Wake County where, what do they call those? Municipal water companies have gone in and drilled some wells. You know what I'm going to say, don't you? And they've drilled their wells 800 feet deep. And guess what happened to the residential wells that were only 200 feet deep? They're running out of water. So it doesn't make any difference the water you're talking about. Water resources are being stressed today like they really haven't been stressed much in the future. And people don't really care. And why is that? Well, largely because we do too good a job of making sure that those water resources are there when they want them. So in North Carolina, groundwater is a critical source. It's regulated by DHHS. If you go out and get a permit for a house with a well today, the health department goes out and they'll inspect that well and make sure it was installed the way it's supposed to be. Well drillers are registered and trained and certified. We've got good programs for on-site water use. Looking more and more at sampling and property transfer across the state, looking more and more at doing well protection programs around the state. And, you know, once water is used, what does it become? It becomes wastewater. So our wastewater management programs, regardless of whether it's a surface water supply or groundwater supply, our water programs are typically looking at reuse. I know somebody in the audience is from this area right here. And when you look at that area right there, there are naturally occurring contaminants in that groundwater, arsenic and lead, naturally occurring. Mother Nature put them there a couple million years ago when those slate belt soils were forming. So, you know, we have to have programs that look very aggressively at looking at water quality, regardless of the source, to make sure that those water resources are suitable for people. Now, the good news about lead and art, we can treat that. We can do a good job of treating for that, but we've got to know it's there, okay? And again, once we use it, it becomes wastewater. Stormwater is a little bit of an exception. We haven't used it, but it's flowed over some surface and it's picked up pollutants as it moves over that surface. Wastewater, again, two types. Domestic wastewater could be black water or gray water. There was one up there for municipal. I don't know what happened. There was another little bullet that said municipal. And again, it's the same thing. And I know some of you have done a lot of work with municipal wastewater. Most of my work has been with smaller systems, on-site systems, a couple of water reuse systems. And regardless of the quality or the source or the type of water, if we're going to use it, if we're going to discharge it to land, or if we're going to discharge it to water, we've got to treat it. If we're going to reuse that water, we've got to treat it to a much higher standard. Those standards in North Carolina are covered in the, this is a test. Do you remember the rule? The 2U rule? 2U, right? 2U. 15A NCAC 02U. So it's not 2U, it's the 2U rule. And these standards for water reuse are very, very stringent. And they're going to become even more stringent because of some work that's ongoing at EPA. With proper treatment, that's the operative word, with proper treatment, all of those sources of water can be recycled and reused very, very safely. They can be discharged into receiver environments very, very effectively. We have requirements in rule that's based on what the acceptable load is in these waterways around the state. Those are called the total maximum daily load, TMDLs. And all of our treatment systems, regardless of how we use that water, have to meet those standards. And it's a great standard. North Carolina, in my opinion, is doing a great job of protecting and managing our water resources. What if we don't do the job properly? Well, you can pick up the newspaper any time of the year and read about fish kills. And I don't know if you've been down on the lower Neuse River when there's a fish kill down there, but it can be pretty smelly. And I wouldn't want to go in that water. Recently, what are you hearing about some of the algae in North Carolina? Anybody? Anybody heard about hazardous algal blooms, HABs? They're occurring all over the state. Hot weather, lack of water, algae growth. Algae are going to grow as soon as there's a little bit of sunlight. We're seeing more and more instances of hazardous algal blooms all across the state. The Chowan River, anybody live on the Chowan River? Chowan River recently had an HAB advisory. And, you know, it's something that's happening all over. So we can do a good job of treatment. How do we deal with this? We try to take the nutrients out of the water as best we can. What are those sources of nutrient? In the Chowan River Basin, 5% of the input is from municipalities. Where's the other 95% coming from? I'm sorry, what? Oh, no. Agriculture feeds you 3 times a day. It doesn't pollute. Okay. Remember my department. It's the agricultural engineering department. Yeah. Okay. And we've got effective ways of dealing with agricultural waste, agricultural runoff. We really do. But we need to have programs that allow us to implement those efforts. Stormwater, another source. Anybody remember Joe Phillips? When I was in the soil science department, Joe Phillips was, you remember Joe? Joe, great guy. And he was the one who was responsible for developing the sedimentation erosion control plan program in North Carolina. Why did they develop that? Well, if you look at sources of pollutants in surface waters, stormwater and sediment is one of the major sources of pollution in our surface waters. And it's a very significant amount. Stormwater does, or sediments do contain nutrients and microorganisms, and they can cause a problem. And, you know, some of this is coming off of the street, of the parking lot. And some of this is coming off agricultural land. So all of these sources of pollutants have to be addressed very effectively. Can we do it? Yes, we can do it. But it takes management programs. It takes certified, competent operators to do the work. We've got options for treating at the end of the pipe. We've got options for treating distributed systems. Nobody deals with this. I do. We can remove a significant amount of pollutant from stormwater, large municipal stormwater systems by looking at distributed management of basins, the stormwater basins. I did work with constructed wetlands for treating large sources of wastewater, and these constructed wetlands do a great job. We can take the water out of there and we can reuse it back in that happens to be an industry. We can reuse that water back in that industry for cooling water and some other things following treatment. This is a stormwater basin. I took the grate off to take the picture. This is a basin insert. When the basin insert is trapping a lot of vegetation, you just ate a little bit of vegetation. What did that vegetation contain? What are the three essential plant nutrients? N, P, and K. You put it on your lawn all the time. Nitrogen, phosphorus, and potassium. 1,000 pounds of that stuff is going to contain about 20 pounds of nitrogen. I can trap in one basin about 1,000 pounds of solids every year. Okay, this is in a residential neighborhood. That's 1,000 pounds of solids. That's 20 pounds of nutrient. When you look around your neighborhood, when you walk through your neighborhood, how many of these basins, these small basins, typically 24 inches in diameter or less with an outlet 24 inches diameter, how many of those basins do you see? In this particular development, there are 70 total basins. 50 of them are single inlet basins. In that basin, in that watershed, it's a tributary of Crabtree Creek. I talk too fast. My brain talks faster than my mouth. We can trap 50 times 20, 1,000 pounds of nitrogen in one relatively small watershed in a year. That's a significant amount of nutrient, and that's a significant amount of nutrient that can be credited to the city of Raleigh's TMDL for nitrogen removal. Those are the kinds of things that people need to think about, is how can we use this distributed stormwater system to manage or to help manage the nutrient input from these larger municipalities. So distributed stormwater, that's one of the things I want to talk about and have talked about. And all of those solids here, I keep putting it that screen, all of those solids we can take out and compost. We take the compost and sell it to people in the community. So it's a win-win for the environment. It's a win-win for people who want to use that compost on their land. These pond and wetland systems do a great job of accumulating solids, and eventually those solids are going to have to be removed. They have to dredge, and that can require a significant amount of time. I can clean this basin out in about 20 minutes with a vacuum truck. I can do that subdivision with the 50 basin inserts in just a couple of days, and I've removed all of those solids, and I have removed thousands of pounds of nitrogen and hundreds of pounds of phosphorus with those materials. So distributed stormwater. The one I love the most is wastewater, because that's the one that people don't want to talk about. Yeah, we all poop and pee, but nobody wants to talk about it. What's the first developmental lesson that a parent teaches their children? We can thank Dr. Freud. Oh, you pooped in your diaper, or oh, you peed in your diaper. Oh, don't touch it, I'll take care of it. Dave, what do we deal with every day? We deal with poop and pee. We deal with people who go down in collection systems and work with poop and pee. I'm proud of what we do. I'm proud of the accomplishments that we have made dealing with poop and pee all over the world. I've been working on a project with the Gates Foundation for the last couple of years. I have had the opportunity to travel to China, to India, to Africa, and looked at the way they treat poop and pee in some of these countries. And believe me, it would make you sick, not just physically, biologically sick, but you look at some of this and it makes you just aesthetically sick that people have to deal with this. We're making progress on dealing with poop and pee all over the country. Municipally, we've got more advanced treatment technologies, better nutrient removal, the biosolids that we generate are used more and more effectively for agricultural production. On the on-site wastewater side, I've done a lot of work with land-based treatment systems, and we continue to rely on land-based systems, especially with water reuse. If with this meeting, we're at the other part of the faculty club over there, on the other side of campus, that whole golf course is irrigated with reclaimed water. Okay. Governor's Club in Chapel Hill, reclaimed water. Reclaimed water is the future, not just for on-site systems or decentralized systems, but for some of these municipal systems. And we're seeing it all over the country. People are looking at water reuse. Are any of you familiar with RAP? And it's not the kind of thing that you put around lettuce and chicken and call it a whatever wrap. Anybody familiar with RAP? It's an EPA program. It really is. It's the Water Reuse Action Plan. And if anybody is interested in RAP for your company, for civic groups, whatever, please let me know. Go to the EPA website, type in RAP, and you'll find all kinds of information about water reuse. It will be driving the water management industry in the future. And why are we able to do water reuse at the municipal level? Because we've got increasingly stringent treatment levels that are associated with our discharges, and that water ought to be reused. What are some of the advantages of putting water on land? You irrigate a crop. What else do you do? What happens to streams and rivers in the middle of the summer? They dry up. What maintains the flow in those streams and rivers when there is no rain? Base flow, right? Base flow. How do we improve base flow? We add water to the land so it forms shallow, it gets into the shallow groundwater and maintains base flow in those receiving streams. There's lots of advantages to land-based treatment, and ecosystem advantages are really significant. We can do that at the on-site level. We can do that with the larger municipal systems. We're seeing at the on-site level systems that treat and reuse water. We've got a park in North Raleigh. Dave, I don't know if you worked on that when we were working for the same company. They have a water reuse system at this park. They take the water from the ranger station and from the bathroom, treat it and recycle it, and they flush toilets with it. We've got a couple of facilities in North Carolina now that are treating wastewater and using it for toilet flush. It is covered in the North Carolina Building Code. You can reuse water under the North Carolina Building Code, okay? Really important. On-site water systems, and again, this is what I've done most of my work in. We're going to have a new rule, the 18E rule, by 2024. The 18E rule specifically mentions on-site water reuse. It specifically mentions water quality that's associated with on-site reuse, okay? So we have lots of opportunities out there to demonstrate reuse. We have lots of new technologies that are coming onto the market, and they're considered this accepted system. An accepted system is comparable to a conventional gravel system. And when a technology is designated as an accepted system, you can substitute it for a conventional gravel system. Why do you want to do that? Think about it for just a minute. With a gravel system, what do you have to do? You got to dig a hole, trench. I got to put a bunch of gravel in the bottom. In order to do that, I drive across that site many, many times with heavy equipment compacting the soil. With these alternatives, with these accepted alternatives, I can pick up 100 feet of pipe and carry it myself. I don't need heavy equipment. Once I dig that hole, I don't need heavy equipment to compact the soil carrying gravel out into the field. So there's lots of advantages to using some of these accepted alternatives. You can see one of them is this fiber wrap pipe. We used a small excavator. It's a very shallow buried so that there's a maximum amount of evaporation, evapotranspiration out of there. And because it's shallow, we're using the entire soil profile, or almost the entire soil profile, to treat the water. Soil is a great treatment mechanism. I am not a biblical scholar. Does anybody know what Deuteronomy 23:12 says? No, I have a homework assignment for you. Go home and look at 23:12. It says you'll have a place away from camp and take that which comes from thee. Everybody knows what that which comes from thee is, right? And put it on the land. It's really that simple. So check me on that. We have mandates to use the land for treatment. How many people remember the story of Hercules and his tasks? He was required to clean out a stable. How did he do that? He diverted the river. What happened when he diverted the river and sent the bill to the king? King didn't pay the bill. What did Hercules do? How many consultants do we have here? What did Hercules do? He went back and gouged out the king's eyes. Now, I'm not suggesting that consultants gouge out the eyes of clients who don't pay the bill. But, you know, looking back in history and looking back in mythology, there's a lot of stuff about water management and wastewater management, and it really is fascinating. It's true. I'm not making this up. So what do we see in the future? Water reuse. I believe we're going to see more and more water reuse. I've worked with Gene in the past. I've worked with Dave in the past. We worked on some water reuse efforts. That's when they were in their infancy. We're seeing more and more emphasis on those, and we're going to see more in the future. We've got to manage our water resources more effectively. I mentioned the RAP. That's WRAP, not RAP. I don't do rap. Okay, I'm just boring. I don't do rap. But look at that. There's a great deal of information in there that'll benefit municipalities. It'll benefit individual on-site systems. It'll benefit the way we manage water. It's a truly great document. And part of what's required in there, I'm going to talk about more, are some of the criteria that we're going to be using to measure the quality of water. What is driving our programs? What drives our programs, and I feel very strongly about this, is sound science. We're developing our programs based on what science tells us, not how we feel about something. I don't feel like we should have to recycle water, but science tells me I have to. I don't feel like I ought to do a lot of things, but science tells me I have to, okay? So our programs have to be based on science. And reuse is a part of our future. So is this reuse necessary? Yep, it is necessary. Why am I showing the picture of an iceberg from somewhere? Oh, the Antarctic. That thing calved in 2020. It's as big as the state of Rhode Island. Huh? Question? Comment? Okay, it's as big as the state of Rhode Island, and it was quite thick. It was my recollection, it was about 500 feet thick. It calved in 2020. It was gone by 2022. So an iceberg the size of Rhode Island calved. All of that water went somewhere. Where'd it go? Right in the ocean. What happens to sea level rise? And are we experiencing sea level rise in eastern North Carolina? Yeah, we are. So please, folks, all of this stuff is related. And what is science? This is climate science. But what is science telling us about the future of water management? We've got to do a better job. We just have to. If you were living up in the mountains in Nepal, where do you get your water? You get your water from glaciers. What's happening to those glaciers? They're drying up. They're melting. What's going to happen to the billions of people who live in South Asia? They rely on that glacial melt. Glaciers are going away. Reuse is going to be essential for those folks. Weather patterns, whether you like it or not, whether you believe in changing climate, I don't care whether you believe in it. Our science is telling us that climate is changing. Our science is telling us that we have had some impact on that. Some of it is natural and some of it is anthropogenic. We have had an impact. We've got to deal with our impacts. It's important for our future, and reuse is a part of that. This is my philosophy. Science seeks facts, is generated through experiment and evidence. We've got to develop that evidence, and that's what we do as researchers at the university. Policy is different than science, and that seeks consensus through public perception, opinion, and compromise. Hopefully, there's more science that goes into policy in the future than there. I'm going to stop right there. The more science that goes into policy in the future. Okay, there we go. And science-based policy and incentive and regulation provides the incentive for change. Okay, and that's why I think this science base is so critical and so important. Science has supported resilient infrastructure. How many remember the lagoon system that the city of Raleigh had over at the interchange where 40 and 440 and all of them merge? The city of Raleigh, up until the 60s or so, had a huge lagoon system. Today, could we discharge the wastewater from the city of Raleigh into a lagoon, into the Neuse River? Absolutely no way. So we've seen tremendous advances that have been incorporated into design of facilities. And science has supported that, both for the large municipal systems and for the decentralized or distributed infrastructure. And what drives that science with a purpose? Change. Atmospheric change, groundwater change, whatever it happens to be. Science with a purpose is driven by need and driven by changing conditions. Rainfall I've talked about before, and when you look at changes in rainfall patterns, east versus west, dramatic differences. When you compare precipitation, just be thankful you don't live in the western part of the country, because they are really going to be in trouble. That's where I'm from, and I would never move back because it's too much challenge. This was what, a month ago? And you can see, I mentioned earlier that much of North Carolina, eastern and central, was in droughty conditions. Well, we've had some rain, thank goodness, and that's dealt with that. That we haven't replenished our groundwater supplies. And groundwater supplies here continue to drop. So it's a challenge. And again, reuse is emerging all around the world. I've mentioned I've worked with the Gates Foundation recently, and it's fascinating work. And one of the things they're looking at is developing these water reuse efforts, and the reinvented toilet. Have you heard about the reinvented toilet? It is approved by ANSI and the International Organization for Standards. It is a standalone treatment system for human waste, and it recycles all of the water that's generated through poop and pee, and the solids that are generated meet the criteria in 40 CFR 503 for reuse. And it's a standalone device, uses solar energy. You pour a cup of water in it, and it'll sustain that cup of water use indefinitely. So some really interesting innovation that's ongoing. We have some reuse rules. A 02U rule here in North Carolina does address water reuse. We have a very interesting project that is in early stages of development. We're reusing water from a farming operation where the processing part of that, we're treating that water. We're going to be reusing that water for agricultural production. We're going to be taking the water from that facility, and they're repurposing shipping containers into classrooms and various activities on the property. We'll be reusing that water for toilet flush in that building, as well as stormwater for reuse in that building. So it's amazing what we can do if we really think about looking at water resources holistically. This is the Wilkerson Park right across the street from the Raleigh water plant. That is the wastewater system. It is treating to the 2U standards, and the water has been recycled for toilet flush for about 8 years. The turbidity in the water has been below 1. We've never detected any fecal coliform organisms. The BOD in that water has typically been below 2 in that system. So we can do a good job with these recycle reuse systems. Our values, you can see our results, less than 5, ammonia less than 2, E. coli, we haven't had detections. Our standard is 3 in 100. We've never had a detection. If you're going to design a system in North Carolina, comply with the 2U rules or the 18E rules. It's clear what's required. And this, to me, is the most important part of this whole presentation. What's coming in the future are what we call log reduction credits. Okay, so there's a performance standard. Performance standard says I've got to meet. Yes, I take a little long. The performance standard right now says that the coliform level in the water has to be below 3, but it doesn't say what the coliform level coming into that treatment plant is. So I may be able to treat XYZ water with an incoming coliform level of 1 million down to 3. That's about a 6 log reduction in bacteria, okay? From 1 million to almost 1, okay? But what happens when that bacterial level gets to 10 million? What log reduction values do is tell you how that treatment process will work under stress. And that's really important. So what's coming in rules in the future are log reduction targets for wastewater for indoor use, wastewater for irrigation, gray water for indoor use, and surface stormwater, for indoor uses. And you'll notice these log reduction values are different. They're different for bacteria, for protozoans. Protozoans filter really easily, but they don't disinfect with chlorine very easily. And then the viruses are the ones that have the highest log reduction values. Why is that? Let me think. Monkeypox is one reason, and COVID is another reason. Viruses are the things that cause the diseases that most affect us right now. So these log reduction values for those organisms are extremely, extremely high. And we're going to see that in rules all over the country. North Carolina currently does use log reduction values, but they're not quite this stringent. And we will be making our indicators more stringent. We got a bunch of examples of reuse around the country. Biggest, I guess, is Chatham Park, the 7,000 home development in Chatham County. And that's supposed to be a reuse system. Great opportunities. Permitting, I mentioned what I want to get to in the most important part. The second most important part, the most important was log reductions. The International Plumbing Code is used in North Carolina. Section 709 talks about permits and connections and all that stuff, okay? If you're the designer of a water reuse system that's going indoors, then you have to comply with section, whoops, that should have been section 9. Section 9 talks about pre and post occupancy issues. You, the designer, have to certify that that system meets your design. Requires you as the designer to go out and look at that. To me, that is extremely powerful because it gets the designers involved in certifying their systems. So, reclaimed water. We can use it for any number of things. In fact, we can now in North Carolina put it back in the water intake to a surface water supply or from a surface water supply. 25% of the capacity can be treated wastewater. Distributed water, again, based on sound science, we're going to see more and more of that. We are seeing more and more of that with individual homes and small residential distributed, whatever you call them, shopping centers and all that stuff in North Carolina. So we're seeing distributed reuse. What in the world is that there for? This has been a very, very crash course. What I hope is that I've introduced you to some concepts of water reuse. The soil. Why is the soil so important? What's that mandate again? Deuteronomy what? 23:12. You can check me on your emails or not emails, whatever you call that. ASCE. Thank you. I'm old. I don't know this stuff. Soil. It's going to be really important as we look at water management in the future because it does a lot of things. Ecosystem advantages. Base flow, all kinds of stuff. Treatment and dispersal technologies, they continue to evolve, they continue to grow. Great opportunities. Management, we got to manage all this stuff. It's not going to go away. I don't care what level, you've got to manage infrastructure. And if we do it right, actually that's not true. If you do it right, we will avoid crashes. And that's the goal of this talk today, was to help avoid crashes in the future. So I told you I'd be done at 4:45. I'm 5 minutes over. I apologize. Does anybody have any questions or comments? Yes, sir. Would you identify yourself